What's going on, everybody? Justin here again. Hey, today we're going to talk to you about hurricane preparedness, more specifically prepared for a power outage. Now, a lot of times when people talk about having a generator, they look at a whole home Generac, a Kohler, something of that nature. It's got a natural gas line coming in, some big switch that changes over to where you transfer the whole home and still be able to use everything that you have normally running, but you do it off a generator source instead of running off of the electrical utilities. So there's other options involved to where if you have a portable generator, say a 30 amp, 12240 volt, or a 50 amp generator, to where you can still use that to tie into your home's wiring instead of running extension cords everywhere. So let me show you what we've got going on. This is a newer constructed home here in this neighborhood. And so with recent code changes, services for new construction houses have to have a main disconnecting mains. So what most manufacturers have done, they've made a panel, whether it's a combo one like this has the meter and the breaker, the panel board section, all in one, or a separate meter and a separate panel, they've put the main breakers in. So luckily with this setup, when we started looking into it, there was actually the accessory kit to where this normal dead front, this panel here is called a dead front. So this panel here just had a cutout for the main. So we ordered an accessory kit for this one to where this interlock kit here is now bolted in behind this dead front. What that does is, in the event of a power failure, you won't have power coming through here to feed everything behind. Instead, we're going to be plugging into this generator inlet here that will come back and feed to this breaker. Now, if we turn this on right now, we're going to send power to these male ends of this twist lock tie-in, and we don't want to do that. But the flip side of that is if this stayed on, this is tied back through the meter, and then this particular one goes underground, sometimes it's overhead, and it ties back into a box, and then it goes out to the grid hitting transformers. If we were to backfeed generator power through this main all the way back to the grid, the transformer will be fed backwards up in the voltage, and it makes that a hazard to the linemen trying to make the repairs. So we want to prevent that with this mechanical interlock. Once this breaker goes off, this will slide up and then go over, allowing this breaker to be turned on. When it's on, now this tab won't be able to go down, and then that breaker has to stay off, so you'll only be able to use one at a time. So then that prevents one from energizing this end of it, which would be a hazard to the homeowner, and then also prevents sending power back to that could hurt a lineman down the road. So show you real quick kind of what's going on behind here. So safety note number one is don't go into one of these panels live, especially if you're unfamiliar with the hazards that are involved with electrical and being around live electrical components. So this is the bus work that I was talking about behind. The breaker's on, feeds here, feeds the breakers. Whenever that's off and we turn on the back feed, generator's gonna feed in and then back feed these breakers. We'll be able to feed these breakers back feeding through here, but not to the road. And then it goes into the home, feeds the indoor panel, feeds the range, feeds whatever you choose to use within the capacity of your particular generator. So this is kind of how this setup is gonna be here. Now, this particular setup is 120 volts, 240 volts, 50 amps. You can run a lot of stuff with that. That's usually one of the larger size portable generators. You have the option to get a generator inlet that will be 30 amp rated. So there's a lot of different configurations you can do. If you, let's say you're in an area and you don't have natural gas and you can't do a whole home generator or something of that nature, you can get a portable generator. You can do this interlock setup, and then you can still use a lot of your stuff in your home without having to run extension cords everywhere. So it's a really nice, neat setup. Now, let's say you have an older home and you don't have the option to order this kit and there's no main. Let's say you just have 6 breakers there. There is an option where we can take the indoor panel feed. This particular breaker feeds the panel that's inside that has all the normal stuff that feeds bedrooms, kitchen receptacles, lights, stuff like that. We can actually come over, hit a switch on the outside that'll be in a up position for the utility power, off position from each, and then it goes down, then it's the generator, and then we'll wire in one of these on this side to where it'll actually break through it and still prevent us from backfeeding back. it just kind of limits your options a little bit. So most of the time your portable generators aren't going to handle air conditionings and stuff of that nature. There's stuff that can be altered to where sometimes it'll run it, but usually pretty hard pressed to do that kind of heavy of a startup of a load. Not trying to get too deep into it, but this is kind of the rundown of how this is. Service, main breaker, generator inlet. We've got a cord made up to where the generator can be set over here. It'll tie in, and then they can keep on going even in the event of a power failure. That's where we're at. That's what we've been up to today. Just kind of want to share that with you. Give us a shout out, give some comments, let us know what you think about it, and we'll see you on the next one. Have a great day.